Welcome back. So we'll just continue on with our particular examples that we've got going here. Okay, so the bakery estimates that the weekly cost in dollars of producing loaves will be Cx given by this cubic. Use calculator to determine the minimum cost. So this time we're using calculus not to determine a maximum, but a minimum. So we need to take this guy here and we need to assign the derivative. I'll just put that back to blue. Assign the derivative to 0. So that before we can do that, we have to actually make that 0. So let's do c dash of x, which will be equal to 3 will come out the front. 3 times 2 will be 0.006. 3 2s are 6. And 2 will come off, 1 will come off and become 2. 2 will come out multiplied by 0.84, which is 1.68. So it'll be minus 1.68 x. Plus 69 will just give you plus 69. And the constant is a gradient of 0, so it's gone. We don't even write it. Okay. Now, if we have this in this particular form, don't want to deal with the decimals, so if we divide by 0.006, what we'll get is 1 at the front coefficient and some larger numbers out the back here. So that'll be 1 x squared, so that's easy. 1.68 has 600 times in it 280 times, so there'll be 280 x. And 69 has 0.006 in it, 11,000 times. That's 11,500 times to be precise. Okay. All right, so we've managed to do that. Now we're going to set it to 0. So that means we're going to solve. And what do we do on this solve? We're going to get the values where c, a function, m is 0. We're going to get the values where, so we get the x values in this case, where it's 0, where m is 0. So we're going to solve this one. Now, it's a quadratic, so the easiest way is probably to use the quadratic formula, where we'll have a plus and minus. So x will be equal to minus b, so be careful, minus 280, plus or minus the square root of b squared, which is minus 280 squared. So the square will make that a positive. B squared minus 4, a is 1, and c is 1,500. Now I'm not sure how they compare, so I'll check those in a minute. But we've got to divide by 2 lots of a. Okay, so we will get 280 plus or minus square root. Probably not important to step this out, but I think it is. So we've got minus 280 squared. Squared is 78,400. Don't be put off by the larger numbers. Now this one here is only 44,000, so that's pretty good. So 4 times 1 times 11,500 equals 46,000. Okay, so 46,000 divided by 2. So 78,400 minus 46,000, 78,400, 46,000 is equal to 32,400. Okay, which is divide that by 2. I'll take the square root of that. That's very good, which is 180. So we get 280 plus or minus 180 over 2. Now we'll split the fraction. 280 over 2 plus or minus 180 over 2. So 28 is 14, so it's going to be 140 plus or minus, now 18 is 9, so 180 divided by 2 is 90. So we have two values. X is equal to 140 plus 90, which will be 230. And it's also equal to 140 minus 90, which will be 140 minus 100 would be 40, so it's 10 more, 50. So there are two values. Okay, two values which m is equal to 0. Now, which one's a max and which one's a min? Which one's a max and which one's a min? So the nature will be, we can get the second derivative, and the second derivative will look like this. So we've got 2x minus 280. We have to test the values, don't we? So we're going to put in, sorry, not x this time, 230. Everywhere there's an x, we'll put a bracket. Testing the values of x, see if it's a max or a min. Well, I can tell you without doing the calculation, that's 400. 400 minus 300 is still a big positive. Okay, so that one is a min. Okay, let's just check 50. Function notation. 2 lots of 50 is 100. Oh, 100 minus 300 is going to be minus 180. So we're going to get, so that one's a smiley face and this one's a, so this is a max. So x is 50 is a max, and x is 230 is a min. Alright, so at what we could check is our comparison value. So we've got our max and min. I might just get the, although I don't need to do that. Now, is it an absolute min? So we can take a bit of time here to check our values. Is there another min occurring? Is that what that means? Is there another min occurring? Okay. So we've got to check our intervals. So our intervals are going to look like 0, 50, up here will be 230. Now, prior to 50, we said that 50 was a max, so it's increasing. So it's increasing up to the max. So it's increasing in this interval. Okay. And then we've got the max. Okay. And then it's decreasing. It's decreasing. Then we've got a min. And that means this one up here, greater than, is increasing. So it just looks like that's correct. Okay, and what happens when x is greater than 0? So that's this increasing part. So because of these increasing, decreasing changes of sign, okay, these signs are changing. So it's not a case that they're a double root or anything like that. Because it is a cube, and we need to check that because the signs are changing. Okay. Now what's the value at 0 for this function? 50 was... Okay, let's check a couple of values. So C0, let's just put C0 in. We get 7,000. Let's put in C230. We get 2768. Okay, so that value is in fact less than this one. So it's an absolute minimum cost. Okay. Alright, so we do the double checking because we might have different points to start from. Alright, so that's a good one. But the minimum weekly cost then is x is 230. Okay, so x must be 230. Now if we put 230 into the cost, then we say the minimum weekly cost is 2768. So that's answered the question. Alright, so let's have a look at a further question in this one. Find the point P on the line y equals that is closest to the point 60, 0. What is the least distance between the point and 60, 0? So the first thing we better do is sketch this out. So y equals 3x is a steep origin-based line. So we know that y equals x would look like this on a 1-to-1 scale. So y equals 3x is going to be steeper. Okay, so y equals 3x will look like this. Alright, the next thing we've got is x values. X is 60 and y is 0. So if we come along and find this value of 60, it's this one here, 60 along the x-axis, because that's its 0. Okay, that's our x-axis. This is our x-y pair. So the x value is 60 and 0 is y, so we had to interpret that. Okay, and then what we're doing is we're looking for a point. Okay, so if we draw this up at a right angle, I guess, there's a point that's got a distance. Okay, and then we've got these other values. Okay, we've got these other values. And the other values represent a distance from P, from this point P. Find the point P on the line, find this point P on the line that is closest to the 60. What is the least distance between P and 60? So that's the same question. Closest to the 60. So it wants to know that distance. So that distance there is P. So if P's here, will that be longer or shorter than if P was over there? If P was there, would that distance there be longer or shorter? So we're in analysing the distance. I'll just take the y equals x out because we've done our comparison there. We don't need that anymore. Okay, they're just getting in the way. So these guys here represent options, I guess. What would they be? Okay, what if we move P along a little bit to this point? What would it look like? If we moved P along here, what would that look like in terms of a distance? Okay, this one here, what would it look like in terms of a distance? Would it be less than or greater than this D? Okay, so that's the geometric problem, which is quite difficult. Okay, so we've got a point of this one here, which has a coordinate pair of x, and it's on the line, so it has a solution. So if we put y function notation, this is going to seem very, very silly, but if I put an x in there, I'm going to get 3, and x becomes x, right? So that's the value algebraically. Whether we put a 1 in, we'd get 3. If we put a 2 in, we'd get 6. If we put a 0 in, we'd get 0. What happens if we put an x in? Well, it's 3x. So the other part of this is 3x, and we need that because now we've got the distance between 2 points. And the distance between 2 points is the thing that we're trying to minimise, okay? So the distance equation is going to be given as a distance squared, as they always are. Our 2 points, which has values x and 3x. So it's a theoretical exercise. Okay, so P has the footprint x, 3x, and our other point is the origin point, 60 and 0. Okay, so our equation is going to be the square of x and y in point form notation. So it'll be x minus 60 and 3x minus 0. So that will give us our distance. Therefore, taking the square root of both sides, d will be equal to the square root of x minus 60. Now you use this distance formula quite a bit, don't you? It's a version of Pythagoras using points rather than just single numbers. But you can get used to that with a bit more use. Okay, so there is our distance. Alright, so what are we going to do? We're going to find some x, or the optimal x, in the distance formula as a function of x, which it now is, of this particular optimal x, is a minimum to find P because x is in P and evaluate at that value. So the P will be these values, right? That's what we're looking for. All right, how do we do that? Well, we find the derivative of d. D is a function of x. And so we're going to take d function of x and assign it to 0. But before we do that, we need d to the x. So that's going to be a little bit harder because we do need to do some pre-work. D to the x is going to be x minus 60 all squared plus 3x minus 0 all squared raised to the power half. Now we're not done yet because we can clean up some stuff going on in the middle here. Okay, this minus 0 is going to be nothing, but the 3x will become 9x squared. So what we're going to get is our x minus 60 all squared plus this is now 9x squared simply by the algebra. Okay, and all of that is raised to the half. So we've got a rather complicated looking thing. So now we can find the derivative. So the derivative of d is d dash. Now this is a chain rule, isn't it? So we've got to do all of the work. You can use shortcuts and all that kind of stuff, but we're not interested in doing that. Okay, so we've got all of this here. So I'm going to let m equal x minus 60 squared plus 9x squared. Clearly I'm going to need n, so I'm going to let n equal x minus 60. Okay, so I can rewrite m in terms of n, so it's n squared plus 9x squared well, actually I can treat that like a separate term, can't I? So I can just treat that like a separate term there. So I'm going to do that. I'm going to have a chain rule part and a non-chain rule part. So that'll give us 18x squared. So, alright, so I'm going to have dm dn and I'm going to have dn dx. Now the n dx is just 1, so there's a 1 there. Okay, this one here is 2n. Chained together it seems a bit trivial. Okay, but what we're going to also have is the d dx of m, d dm of m to the half. So that's our ddm. We're still going to have our ddm. But we're going to have ddm dm. So ddn dm. So that's all that was needed for that one. So we put those together. And we'll get 1 times 2n, which is 1 times 2x minus 60. This thing here becomes a half, m to the minus a half. So our final part then is so this chain needs to be modified here. Sorry, I've written this out poorly. I do apologise. Okay, I do apologise. Redo this. Yeah, I'm doing it. I'm doing the working. If I skip the working and just put the results, I don't have to be accountable, but I'm trying to be accountable, so let's do that. So d dx, which is what we needed, is still going to be d dx, but it's going to be dm dn dm dn and dn dx. So that's the correct one. So ddm is this one here, which is 1 over 2 the square root of m. That's this bit. The mdn is 2n, and the ndx we worked out was 1. So that's the complete chain, if you've been careful. Now we need to put the x's back in, of course. So we'll get 1 over 2 the square root of x minus 60 squared plus 9x squared times 2 times x minus 60, and don't forget to plus this one. So that's just 18x. So the chain was needed for the bits inside, but we were able to do that. Alright, so what we end up with after putting all of that together is a derivative for this one, which is half I'll just jump in there to x expanded 2x minus 120 plus 18x on the top divided by 2x squared plus 9x squared, it's the long one, which is equal to 10x minus 60, taking 2 out as a common factor and cancelling. So 9x plus x is 10x, and then we've got the square root only, 2's been cancelled, of x minus 60 all squared plus 9x squared. So quite an involved chain rule. Okay, and what do we want to do now? We want to have that assigned to 0. So let's do that. So assign it to 0. We can multiply by the square root of both sides. 0 will cancel that out. So we'll get 10x. So in the end, it's not as complicated as it first felt. Okay, and adding 60 to both sides, dividing by 10, x is equal to 6. So after all of that, a minimum occurs at x equals 6. Okay. Now, do you want to go and do d double dash? So that's going to be quite complicated to go through without using a numerical support. So what we might be better off doing is just testing a couple of values. Okay, so let's test a couple of values either side of 6. So take the first derivative and put in some values, and what we'll see is that for our particular value, here we've got our minimum, which is 6. This is now the M curve, so just be mindful of that. So this is our 10x minus 60 curve. Now this is an M curve, so be careful with these M curves because we're interpreting the the curve quite a little bit differently. So in values that are less than 6, we're going to have 10x. So let's say 5. 50 minus 60 gives us a negative. And I think you'll find that if you keep doing that for all the values, you'll continue to get negatives. What about greater than 7? So 70 minus 60 is 10, which is a positive. So it's changing sign, and that's all we need to verify that this is in fact a minimum. Okay? It's changing sign. And that's sufficient to tell us that we've got a minimum. So we simply need to write the answer. Okay? So the answer is P is 6, and then if we do the value for Y, 6, 3 by 6 is 18. 3 sixes are 18. So I wrote that. I said it and I wrote it. I drew it twice. So I'll keep doing that. Okay, so the minimum D is at 6, which is our original equation. Which approximates to 57, nearest integer. Wow. So 57 is the distance between the minimized distance of P to some value, some point on the x-axis. That's the length. 57 is a minimum value. So it's an algebraic idea. It's a bit harder, bit of a harder problem, that one, but nevertheless it shows you the power of calculus, and that you can do that kind of abstraction. All right, I'll come back with more soon.